Okay, welcome back, ladies and gentlemen. This is Dr. Robinson, and we are going to talk about the compositions of transformations. Here's a video that I plan to show in class. So the composition of transformation is a combination of two or more transformations. When the first transformation produces an image, and the second transformation is performed on that image. So we're going to be doing a few things together. So here's our first question. For triangle ABC, reflect it over the y-axis, then take the image of triangle ABC, A prime, B prime, C prime, and reflect it over the line y equals x. Okay, so let's start it off first by finding the y-axis. So here's our y-axis. It goes straight up and down. So that means if it's on the right side, I will put the picture on the left side. So notice I got to put my distance from the triangle. It's going to measure up the same distance from each point from the y-axis. So point A is my first point. It's one box away, so I just go one box away from the line. So there's my point A. Point C is 1, 2, 3, 4, 5 boxes away from the line. So I just go over here to 5 boxes away from the line. And there's my point C. Point B is up here. And I can even count up from point C. So I'll count up 1, 2, 3 boxes up. I can do that. 1, 2, 3 boxes up. Draw a dot right there. Or I can count from this spot here, which is 5 boxes from the line, and count over 5 boxes from the line, and there again I'm at my same spot. So let me connect my dots, and now I have a reflection of triangle ABC over the y-axis. Excuse me. So let's put our points down, labels down. Let's label it. So we got A prime, B prime. I'm sorry, that's not B prime. That's C prime. C prime. And up here, E prime. Okay, so there is our first reflection. Now, we have to reflect over the line y is equal to x. If you remember, when we were dealing with slope, we had a formula for the slope-intercept form of the equation, y equal mx plus b, where m was our slope, which is the coefficient of the x, and that tells us how many boxes to go up and down, and we would graph our points. So 1, 1 would be a point. So I'm sorry, we would start first at our y-intercept, which is the b, which is at 0, 0, the origin, since there is no number there. Then we would go up 1, over 1, draw a dot, up 1, over 1, up 1, over 1, up 1, over 1. So we'd be at the same number as y is equal to x. So it goes straight up the middle. So let's get our line tool. And let's go to, say, 5, negative 5. And go straight through the origin and straight up. Okay, so now we want to reflect it over this line. Well, if you remember in class, I taught you a trick. You can go to the point, like point A, and reverse the numbers on the coordinate. So coordinate for point A would be -1, 2. So we can now, remember in the rule, since we're going on the opposite side of the line, all we have to do is go to the opposite of the numbers, and we would put a dot, get my dot, my construction tool, at 2, -1. All we have to do is reverse it. So 2, -1, and that would be point A. Or you can count how many lines, how many boxes to the line. So I'll count it, 1, 2, and I'm on the line, and I'll go in the opposite direction, going down. Did I count right? I'm sorry, I didn't count right. All right, 1, 2, 3. 3 boxes to the line. Now count down. 1, 2, 3. And there it is, that point A. So now I can also look at my letter C and look at that coordinate, which is -5, 2, and reverse it and draw a dot. So let me get my tool. So I got -5, 2. So I go to 2, -5. So go down to 2, -5. And there's my second point. That's my letter C. And now I'll look at this one. This is -5, 5. And I'll reverse that. 5, -5. 5, -5, which is over here. And now connect that. And there is my reflection over the y-axis. I'm sorry, over the line y equal to x. So y equal x is the name of this line, and this point, by the way, was -5, 5. So -5, 5. And all I did was just switch places with the point, or you can count how many boxes it is from this line and then go straight down and you'll get to that point. So there's your point B double prime, and count from here and then go down. There's your A double prime, and count from C over to here and go straight down, and there's your C double prime. And you have just reflected and did what's called a composition transformation, where you did 2 things. You reflected this first over the y-axis there, so that's what it looks like over the y-axis. Then you reflected it over this line, y is equal to x. Good problem. So that's a lot to do, so you're going to be required to do a lot of stuff. So your rules will help. Go over your rules, watch the video again. Here's a question for you to try. It's similar to the one we just did, so hopefully you'll get it. If you need to watch the movie again, please do. If you're still uncertain, write down your questions, bring them in, and I'll be glad to go over them with you. Here's a series of transformations to this shape that we're going to do, so let's look at it. So here's all the different transformations we're going to do. We're going to end up listing the coordinates of the rectangle from part E. Please note the transformation is applied to the image of the previous transformation, not the original image. So here we have our first transformation. We're going to take point xy and we're going to add 7 to x and add and subtract 2 from y. So let's get a dot, get my tool again. So I'll start with point B. I'm going to add 7 to this point on the x-axis. 1, 2, 3, 4, 5, 6, 7, and then I'm going to go down from there on by 2 boxes on the y-axis. 1, 2, and there I am. That's my new point B. And I'll call that B prime. So I do that with each and every one of my points. So since it's a rectangle, I'm going to be moving this distance from here to here, and if I count the boxes over, it's 1, 2, 3, 4 boxes wide. So all I need to do is count 4 boxes wide, and I'll have my top of this shape. 1, 2, 3, 4. So there is point A prime. So distance is preserved when you're just translating. This is a translation. So the same distance from A prime to B prime is going to be the same as in the original triangle, because this is a translation. It just slides that. So let's count down. 1, 2 boxes. So all I have to do is count down 2 boxes, get my dot tool, and 1, 2, draw a dot. There's D, and again it's 4 boxes across, so I go over 4 boxes, and there is my point D. So I have just translated this figure. So the shape is there, and that's what it looks like. A prime, B prime, C prime. So all that was a translation. All right, let's look at the next one. It says for point xy, we're going to leave x alone and make y its opposite. So we're going to negate it. So whatever y is, we're going to make it its opposite. So let's take point D. Since point D is right here at 1, 4, so let's write that down. 1, 1, 4, 1, 4. So that's point D. All I have to do is what the rule says, make y its opposite. Leave x alone and leave D and take the y and make it the opposite. So my x would be 1 and my y would be -4. So that would be where point D is. So 1, -4. Now, as I said before, distance is preserved. So if you look at from A to D, we said that was 2 boxes. So that's point D. So let me go down 2 boxes. How did I know to go down? Is because from A to D, from A to the x-axis, if I count down, because I'm keeping the same reflection, so it's changing. It goes from here to the x-axis, a total of 6 boxes. So I have to go down a total of 6 boxes, and that would give me point A, letter A. So let's label these. So we got D prime, and we got A prime. Because remember, the distance is preserved, doesn't change. And we said before that this is 4 boxes wide, so all I have to do is go 4 boxes over. So 1, 2, 3, 4, and draw a dot. So let's go again. 1, 2, 3, 4. So it'll be right here. Or I could take this coordinate, let's see which coordinate. I'm lined up with C. So C, I can take this coordinate C and make it the opposite y value. So this coordinate C is equal to to 5, 4. So 5, 4. And all I got to do is make the opposite of the letter Y, which will be 5, negative 4. And that's this point right here. 5, negative 4. 5, negative 4. Okay. So that's point C prime. And again, distance is preserved. So I'll use my tool to go down 2 boxes from C prime, which will give me letter D. So now I have a dot for B, for C, same distance, for D, A, and back to D. And there is my shape. So we've done our second transformation, and there it is. So our next transformation says rotate clockwise around the origin. When we go clockwise, we're going to the right, if you remember from my other video about rotations. So we're turning it to the right. So if it's like 6 o'clock, we got to go back around to this side. So it's going to end up somewhere in this quadrant. If you remember the rule for rotation, I believe it is you switch the coordinates, and y would equal the first coordinate, and we negate the second coordinate. So we have to switch places with the coordinate and negate the second one because we're doing a clockwise rotation. So this point D, let's take that for instance. This point is 1, negative 4. So this is 1, negative 4. So we're going to switch it and make it negative 4 and negate the 1 and make that negative 1. So our D is going to be right here. So that'll be D. Now I would go, since that's D, I'm going to go to A and switch, and that coordinate is 1, negative 6. So I'm going to switch that and make that negative 6, 1, negative 1. Because again, I switch places with the X and Y and negate the second coordinate, which is the X now. And that'll be A. So let's make a list of our coordinate. So this is D, and this is A. All right. Now let's take the C coordinate, which is 5, negative 4. Let's switch it. It'll be negative 4, negative 5, which is down here. And let's get our tool again. So again, it's switched. So negative 4, negative 5 is down here. And if you look, D and C are on the same side, so C's have to be there. And if you also check, it's got to be 4 boxes in between them. So that's going to be that right there. So we got just to fill out B. So B will be right there, 2 boxes, which is the same distance as the top. And let's close it out. There is our rotation. So that's what it looks like when we rotate it again. So it's standing up now. All right. So, boy, this is a lot of work. But that's what it is with um, compositions. So our next thing we're going to do on, so that was the rotation. Remember the rule, change places with Y and X, and then negate the second one, the X. So now we're going to take our X and Y and add 5 to X and add Y to 3 to Y. So if I take point D, let me get my tool, take point D, and I add 5 to the X coordinate. So let's go to the X coordinate and add 5. 1, 2, 3, 4, 5. And now add 3 to the Y coordinate. So add 3 to it. 1, 2, 3. D is going to be right there at 1, 2. So I'll take every coordinate and do that. So that's another translation, and let's see what does that look like. Like that. So by lifting that up, and let's clone it so we can see. So if I actually cloned it, you can see that I went over 5. 1, 2, 3, 4, 5, and went up 3 boxes. 1, 2, 3. And it's right on top. So the whole thing moves nice and easy. So that's a translation. All right, last one, E. Now it says X and Y, we're going to take that, and we have 3X. Well, 3X means 3 times X. And we have a 3Y, which means 3 times Y. So this means we're going to take the X coordinate, and we're going to multiply it by 3. So let's get a point again. So let's take point D again since we're up here. This is 1, 2. So D equals 1, 2. Now I got to multiply that by 3. So I'm going to take 1 times 3 and 2 times 3, and that'll give me my new coordinate. 1 times 3 is 3, and 3 times 2 is 6. So my new D prime is going to be 3, 6. So I do that to each coordinate, multiply it. So we're dealing with now a dilation because we're making it bigger. So take each coordinate, find each coordinate, and multiply it by 3, and you'll get your new point. All right, so let's see what that looks like. And there it is. There's D prime, as I said, 3, 6. So now we'd have to write out all the coordinates. So find each coordinate of the rectangle. Here's -1, +2, and that multiply that by 3. You get -3, 6. And here's down here. This is negative. Down here, B, we have -1, -2. If you multiply that by 6, by 3, you get -3, -6. So multiply each one by 3. And there's your new blue triangle. So if you look at it, I'm sorry, rectangle. If you look at it, it compares to the big one. It's got an increased size because we had a scale factor of 3. So when you have a whole number that's greater than 1, you're increasing the size, enlarging it. So let's take a compare. Look at comparing the size and the shape of the final image and to that. So what about the shape? Well, the shapes were the same. It still was a rectangle, even though it was a little rectangle. It still was the same shape. The size we said were different. One was little and it was similar to the other one that was bigger, but the bigger one was 3 times the size. Now the angle measurement, let's go back to the angles. We didn't talk about the angles. There are these little right angles there, and they're all right angles in the 4 corners. So the angles stayed the same, so in both shapes they were right angles, so they were all 90 degrees. So that's a nice comparison to look at. So that's what's called a similar figure. So if you understand, great. If you don't, write down your questions, watch the video again, and bring them in. I'll be glad to work with you with this. This is a good subject. Here's one for you. So just read it over. I'm not going to go over it. Just remember to perform these in order on the new image, not the original image only. So give it a shot. I'll show it to you in class how it goes, and we'll do a comparison on the shape and the final image. So here's another question for you to try. So it's a little bit of drawing needed to be done, so give it a shot. So I hope you got something out of this video. I'm sorry I was a little long, but it was really good. So I will see you next time. This is Dr. Robinson signing off. Bye.